All right, welcome back. So we're going to get right into section 2.3, which gets into more different types of graphs that we could see out there. We saw histograms last time, so now we're going to look at some other types of graphs that you could potentially see. We're only going to be doing a select few of them that will be tested upon, so you're not going to have to know every single graph that's in here. And then we're also going to look at some different types of graphs that are deceptive and why. So if we jump right into our key concept, introduce other common graphs that foster understanding of data, discuss some graphs that are deceptive because they create impressions about data that are somehow misleading or wrong. Technology now provides us with powerful tools for generating a wide variety of graphs. So just take a look at Excel and take a look at all the different types of graphs that you could have in there. There's quite a few. So here's the first one, which are dot plots. Dot plots are nice. They're kind of simplistic in how they look. You can see the multiple dots that are stacked, and generally that just shows the frequency of a specific data value. So you get a nice sense of the distribution from it and whatnot, but we're not going to be using these graphs. So moving into stem plots or stem and leaf plots, it's another way to kind of reframe a frequency distribution. So if you wanted to look at pulse rates of 40 and 42, which are on your slide here, you can see that the 4 part of it is on the left side of the line, which is the stem. And then on the right side is the 0 and the 2, and they're just listed right one after the other. Sometimes they're separated with commas, but not necessarily. And so you got 40 and 42 once you kind of put them back together. So the left side is the stems, the right side are the leaves. So we're not going to be using those either. Time series graphs. Again, this one's fairly straightforward. You got the time across the bottom, and on the vertical side, in this case, they have an example of law enforcement fatalities. So you can track how things trend over time. The coronavirus is a good example of that, how that trends. We're not going to be doing these as well. Pareto charts are kind of like a bar graph. You can see you just have some bars, but it's looking at qualitative data, not quantitative data typically. So in this case, you have the different types of sailboats, and then you have the stolen boats on the vertical side, the number of times they've been stolen. The one thing that is important about a Pareto chart is that it starts with the highest frequency and then it decreases throughout. So in this case, you can kind of see what's going on here, but again, we're not going to be using these ones either. A bar graph, we've talked a little bit about our bar graph when we went through histograms. The one major difference though is that you're going to have spaces between those bars, whereas histogram, they're all squished together. And what's also nice about bar graphs is that you can have multiple ones on the same chart. So an example, you have males and females all on the same chart, and you're looking at the differences in the income, in this case, the median income in thousands of dollars. And you can definitely make some conclusions based off of that. In this case, you can see that men have traditionally been paid more than women. Terrible, terrible, terrible. But we're not going to be explicitly drawing these either. So let's jump right to the next, which are pie charts. Pie charts, you probably know what a pie chart kind of looks like. We will be drawing these. So, but just to describe it, a very common graph that depicts categorical data as slices of a circle in which the size of each slice is proportional to the frequency count for the category. So an example, we have our stolen boats again. So and how it breaks down. So you can see that sailboats, for the most part, aren't stolen very often, whereas jet skis are primarily the main ones that are stolen. So they're pretty informative, but we're going to see how we can draw them without too much difficulty and not a lot of math per se. So we'll see that soon. The next one we are going to be doing are frequency polygons. So a frequency polygon is a graph using line segments connected to points located directly above class midpoint values. So midpoints are going to be important for these graphs. A variation of the basic frequency polygon is the relative frequency polygon. So remember what relative means. Relative means you're looking at percentages. So we're going to have to make those percentages for the vertical scale. So a couple examples, you can see this one here It's just a traditional frequency distribution. The frequencies are on the vertical scale, just like with the histograms, but across the bottom are the midpoints. So, and this one is a relative frequency one. Again, the vertical scale is now in terms of percents, not just the actual frequencies. So, okay, so that wraps up the different types of graphs. Now the second part of this is just looking at the deceptive nature that could be out there with graphs. So the first one is a very common one. It's a non-zero vertical axis. So if you look at the graph on the left, you can see that the bars are definitely different in height. So you would look at that and say that the Honda Civic has the greatest fuel consumption, so the mileage. So because it's got the highest bar. But the problem is, look at where it starts. It starts at 30. So that's the problem. If you take that same data and fold it into the graph on the right, now starting the bars at 0 and going up to their heights, you can see that the heights of the bars are actually not that much different. So because you're not starting at 0, those differences can be exaggerated quite a bit. So that's a deceptive tactic that places can use to make it seem like they're much better than somebody else. So be careful and be wary of that. Pictographs, using pictures in general, can always be a way to be deceiving, especially when you look at three-dimensional stuff. So just for example, I'm going to kind of just skim through to the middle. It says, if you double each side of a square, the area does not merely double. It increases by a factor of 4. So if you have some geometry knowledge, that kind of makes sense to you. And especially when you go 3 dimensions and you're looking at the volume of something, it gets even worse. So it says the volume does not merely double, it increases by a factor of 8. So, and you can kind of see that in the next few slides. So here's a case where they're trying to be fancy by using a part of a dollar bill, but it's just making it more convoluted. You can't really see the bars very well. It's just not abundantly clear. It's not a really good graph. So it's too busy. Here's the three-dimensional case. So you can see that the small block on the far left, the 18,000, is a pretty small chunk. But really, if you compare the numerical difference between the first one and the last one, 74,000 is about 4 times as big as the 18,000. But look at the size of the block. The block is humongous. You can fit a lot more than 4 of those little blocks inside of that big box for 74,000. So there's the problem. There's that deceptive nature going on. Here is a nice, fair, objective, unencumbered by distracting features. So this graph is nice. All the bars are the same width. You got the scale that starts at 0 and it increases equally throughout. So all those bars are really easy to compare to one another. So the concluding thoughts: in the visual display of quantitative information, Edward Tufte offers these principles. For small data sets of 20 values or fewer, use a table instead of a graph. So yeah, small data doesn't need a graph. A graph of data should make us focus on the true nature of the data, not on other elements such as eye-catching but distracting design features. Do not distort the data. Construct a graph to reveal the true nature of the data. Almost all of the ink in the graph should be used for the data, not for other design elements. Okay, so that wraps up the PowerPoint part of this section. We're going to focus on those 2 types of graphs in the next video. So see you soon.